Alright, in this last problem we'll go ahead and see if we can simplify some very large powers of I. And since they are very large powers, we'll go ahead and use our shortcut to take care of that process. So in the first one I have I to the 107. Let's start off by taking that exponent, 107, and we'll divide it by 4. This will figure up all of the bunches of I to the 4th that we have hiding in there. Okay? So 4 goes into 10 twice, and we get 8. Okay, subtracting that away, I'd end up with 27. Now that goes in there 6 times. And 6 times 4, that'd be 24. And then we could subtract that away. Okay, so now I'm down to 3, and that's smaller than 4, so I know that 3 is my remainder. Okay, now think back. If my remainder is 3, then what does this entire thing simplify to? Well, it simplifies to a negative I. Now, if you ever forget or you lose that table, you can always build it very quickly by doing just the first few values of I. So I was I squared was our negative 1, then we had negative I, and then positive 1. And then you quickly have built your table. Alright, so on to the next one. I to the 2013, something very large. We will grab the exponent, and we will divide it by 4. Okay, so 4 goes into 20, 5 times, and I get 20 exactly. Let's put in our 0 placeholder over the 1, then bring down the 13. So 4 goes into 13 3 times, and we'll get 12. So this one shows that my remainder is 1. So what does this entire thing simplify down to? So if I get a remainder of, say, 1, 2, 3, or 0, now I know what it'll simplify down into. Simplifies down into just an I. So there's many things you can do to work with these complex numbers, but they often mirror things that you've learned before. Definitely keep track of this handy method for simplifying powers of I. That way you can take those much higher powers and bring them down to something really nice and compact. Thank you for watching Educator.com.